ஓகே ஃபைனலி லைவ் ஸ்டார்ட் ஆகிடுச்சு. இன்றைக்கி வந்து 5.5 மணி நேரம் நான் படித்தாதான் இன்றைக்கி இருக்கிறதே நான் முடிக்க முடியும். அதுக்கு காலையில் சீக்கிரம் எழுந்துக்கணும்னா நான் ரொம்ப லேட்டாக எழுந்துட்டேன். ஸோ இன்றைக்கி எப்படி பிளான் பண்ணதை நான் முடிக்க போகிறேன்னு எனக்கு தெரியல. பட் ஐ ட்ரை மை பெஸ்ட். ஓகே, முதல்ல பிளான் பண்ணது என்ன? ஃபஸ்ட்டு பிளான் பண்ணது 1.5 மணி நேரம் லேப் சொல்யூஷன்ஸ்லாம் கவர் பண்ணுறதுக்கு. So let's get to the lab solutions. Udemy. லேர்னிங் சொல்ல போனால் ஒன்றுமே இல்லை. எவ்வளோ இருக்குது? வைஃபை தானே ஓடுது. அது லேண்ட் தானே கனெக்ட் பண்ணி வச்சுருக்கேன். ஓகே, ஸோ லேப் சொல்யூஷன்ஸ்லேருந்து வருவோம். எந்த லேப் சொல்யூஷன்லேருந்து எடுக்கணும்? நம்ம நோட் அஃபினிட்டி லாஸ்ட்டாக அந்த லேப் சொல்யூஷனோட முடித்தோம். அங்கே போவோம். லேப் சொல்யூஷன் 53. அதுக்கடுத்து லேப் சொல்யூஷன் 56. அது 56 எழுதியிருக்கேன். அப்புறம் 59 எழுதியிருக்கேன், டைம்ஸ் அண்ட் டாலரேஷன். அதுக்கடுத்து 63 தான். ஏன்னா 63 எழுதலை, 64 நோட்ஸ். ஸோ 63லேருந்து நோட்ஸ் எழுதணும். ரைட். ஓகே, இப்போ இவனை கொஞ்சம் பின்னாடி தள்ளிட்டா எனக்கு எழுத வசதியாக இருக்கும். ஸோ ஓகே, மூடிய தூக்கி ஓரம் போட்டுட்டு வீடியோ நம்பர் 63 லேப் சொல்யூஷன்ஸ் எதுக்கு? நோட் அஃபினிட்டிக்கு. இந்த பின் சூப்பராக இருக்கும் மக்களே. 2 பின் அவங்க வச்சுருந்துருக்கலாம் போல. நோட் அஃபினிட்டிக்கு பத்து நிமிஷம் வீடியோ. இதை எதை நோட் பண்ணுறோமோ அதை மட்டும் தான் நோட் பண்ண போகிறோம். ஏண்டா ப்ளூடூத் கனெக்ட் ஆகலையா? நாட் கனெக்டட். ஆமாம், எம்ஏ சவுண்ட் பார் connected.
We will go over the practice test for node affinity. So the first question is to identify the labels on node 01. So to count the number of labels on node 01, so let's do a
You'll describe node label
01. And let's look at the labels. So we have 1, 2, 3, 4, 5 labels. So we're going to select 5.
What is
and
the value?
The next question is what is the value set to the label beta.kubernetes.io/arc. So on node 01, so we are already on node 01 and it is AMD64. So that's this one.
Apply.
Okay, so the next question is to apply a label called color equals blue to node 01. So for that we're going to use the kubectl label command. So let's take a look at the help. And here we have some examples. So you have kubectl label, the pods or node, what is the object that we want to apply the label to, and then the node name, and then just the label. So it's pretty straightforward. So we're going to do kubectl label node 01. and then color equals blue.
அதாவது to add a label to node, we can use kubectl label node name அப்புறம் வந்து லேபிள் கலர் ஈக்குவல்ஸ் டு தானே, யா கலர் ஈக்குவல்ஸ் டு ப்ளூ, இதுதான் லேபிள். we can use this above command. Okay.
Let's verify that it's set correctly. We're gonna go back to the labels and we see the color equals blue.
நான் உள்ள ஓபன் பண்ணி அதை எடிட் பண்ணி ரீப்ளேஸ் பண்ணிட்டு இருந்தேன்.
Okay. Now the next
Create
one
a deployment
is to
name
create a new deployment named blue
with
with
engineer
the
for
index
replica
image and
string.
3 replica.
இதெல்லாம் ஈஸி தான் பண்றோம்.
Internet.
ஓகே.
Okay. Scan the pods for the blue
Which nodes
deployment
can
be
the pod
placed
blue
on.
deployment be
So
placed on?
we've got to check the things on both the nodes. So let's do that.
Clear.
Let's
kubectl
check the tains on each one. So we're gonna do we've got to describe
node 1.
Let's check node 01 and let's just check for tains.
Oh.
So there are no tains.
ஓ இப்படி பண்ணலாமா? ஓகே. kubectl kubectl describe தானே, ஆமா kubectl describe node name pipe grep tains. So this command will filter the output only for tains. Super.
Tains set on node 01 and the other node, which I believe is the control plane node. Let's check that too. So there are no nodes on either of the nodes because there are no tains on any of these nodes. Okay, so in this question, the task is to set node affinity to the deployment to place the pod on 01 node. So we're going to edit the deployment. So let's keep edit
deployment.
Blue. So we're here, and what we need to do is
Node
use pod
affinity
specification. We've got to set the node affinity for these, right? So we have to use the required during scheduling, ignore during execution, then use the color and the values to blue. So for this, let's go to the Kubernetes documentation page and let's get this. So I'm going to copy this.
Affinity node affinity required during scheduling, node during execution, அதுக்கடுத்து மேட்ச் நோடு செலக்டர் டேர்ம்ஸ் மேட்ச் எக்ஸ்பிரஷன், அதுக்கடுத்து தான் கீ ஆப்ரேட்டர் வேல்யூ. ஓகே, இதில் மேட்ச் இதில் வந்து ரெக்வயர்ட் டூரிங் ஷெடியூலிங் இன்னும் டூரிங் எக்ஸிக்யூஷனுக்கு அப்புறம் நோன் செலக்டர் டேர்ம்ஸ்க்கு அப்புறம் மேட்ச் எக்ஸ்பிரஷன் அது வந்து லிஸ்ட்டில் வரும், கீ லிஸ்ட்டில் வரும், ஆப்ரேட்டர் அது இன்னு, வேல்யூஸ் லிஸ்ட்டில் வரும். ஒரு வாட்டி எழுதி பார்த்துருவோமா? மெமரி மறந்து வச்சுக்கிறோம் எனக்கு. நோட் affinity examples affinity node affinity affinity node affinity. Next வந்து required during scheduling, ignored during execution. Node selected terms, no, on the list. Node selector terms, now list match expression, then key operator, value. So key வந்து கலர்னா வேல்யூ வந்து ப்ளூவாக இருக்கணும், ஆப்ரேட்டர் இன். ஓகே ஓகே
And paste it here. So here basically this one is an example for a pod, and so all of these are kind of aligned a bit more to the left. But here this is under the pod, which is under the template section of deployment. So we have to move it all a little bit to the right. So for this, what I'm going to do here is the first one is okay, first line is okay, but all these remaining lines we need to move it one step inside. So press capital V and then select all the lines. Then I'm going to do a greater than symbol. So that's shift dot on the keyboard that I'm using. So it moves everything to the right. So it's not very pretty, but I think that will do the job for now. And I'm just going to set the key to color and the value to low. So there are ways that we can set the Vim settings so that this always gets indented with spaces as opposed to multiple spaces at a time that you can see here.
Press capital V, then select all lines.
I'm going to save that. And let's give this a shot. Save that multiple spaces at a time that you can see here. So I'm going to save that. And let's give this a shot. Okay, so that's done. Now the question is to find out which nodes the pods are placed on. So let's run a kubectl get pods that go wide. It kind of shows us that all the pods are all node 01.
Node 1 மட்டும்.
So they're all on node 01. So the next task is to create a new deployment named red, add the Nginx image into replicas, and ensure it gets placed on control plane node only. And the recommendation is to use the label node kubernetes.io/master, which is already set on the control plane node. So if you look at the
describe
control plane node, we see that there is this label, right? It doesn't have a value set, right? So all we need to do is to set a node infinity rule that says the pods that are part, and the label does not have a value, but if this label exists, then that's where it should be placed. Deployment command, and roughly we're going to do a dry run because the node put it to a file named red.yaml.
Okay.
Now we're going to edit that file.
Okay.
And within the spec section,
No affinity.
we're going to do the same as we did before. So we're going to paste it. Now we've got to select all of these lines. I'm going to do a shift dot on my keyboard, which is going to, and that's basically the greater than symbol, and it's going to move it to the right. Now we're going to change this. So the key is the label, which is this. Copy and paste.
Okay.
And as we realize that this label does all operator would be, let's save that.
Save.
And now we're going, there seems to be some error, so let's go back. See what the error is. It's on line 26, do not find expected key. So line 26 is this. Okay, actually it's this line here. So this is not intended, that's the problem. So we're going to move it 2 characters before. Okay, so that. Let's try that again. Okay. So even though here it said line 26, okay, so the new pods are on node control plane. Okay.
So your notes are fine.
Now that we have learned about taints and tolerations and
நீ பாஸ் ஆகு. இப்போ வந்து லேப் சொல்யூஷன் ரிசோர்ஸ் லிமிட். யா ஸோ வீடியோ நம்பர் 68 lab solution resource limits.
okay, so let's go over the labs on resource limits, resource requests and limits. So the first question is, a pod called Rabbit is deployed. Identify the CPU request or requirements set on the pod. So let's do kubectl get pod. And we see, yes, there is Rabbit. So let's do a kubectl describe
Okay.
pod Rabbit. And if you look at this section right here, we have
Limits to
CPU limits and CPU requests. So the CPU request has requested here as 1. So let's select 1. Okay, the next task is to delete the rabbit pod. So delete pod rabbit.
Check.
Okay.
Next.
Okay, now another pod called Elephant has been created, so let's check that. Yep, so we have a pod called Elephant, and it fails to get to a running state. So inspect this pod and identify the reason why it's not running. So let's do a kubectl describe
pod
Elephant. And if you look,
reason.
at this section here called last state, it says the reason is OOM killed, right? So that's basically, that indicates that it's a memory issue. So the reason is OOM killed. So let's select that. So the status OOM killed indicates that it is failing because the pod ran out of memory. Identify the memory limit set on the pod. So the memory limit is, as you can see here,
10 MB.
it's 10 MB, right? So that's the memory limit set on this pod. So the elephant pod runs a process that consumes 15 amount of memory.
Increase the limit to 20 MB.
So increase the limit of the elephant pod to 20, and delete and recreate the pod if required. So one thing we have to do is to change it. So as you can see here, the command used to create this pod is the stress command, and it stresses, so it basically gets the pod to use 15 megabytes of memory, and but the limit is 10, so that's the reason why it's getting killed. So we've got to change this to 20. So one of the ways to do that is to do a kubectl edit
pod
elephant.
name elephant.
But the problem is we might not be able to change the limit
memory
with an edit. So we're going to, let's give it a shot anyway. So let's give it 20 and save. And what this says is that you cannot basically edit the limit set to a running pod. So anyway, let's come out of it. But our changes are saved in this file, so that's a temporary file, right? So let's check that. And if you look at the resource limits that we have set, so it's actually saved here. Our change is saved here. So what we could do is we could just use this file to recreate the pod, right? So we can either delete the pod and then recreate it, or an easier way is to just use the kubectl replace command and then use the force, so it actually deletes the existing pod and recreates it, and give that file. Just change it here, kubectl replace force -f and then the file name. So it basically deletes the elephant pod and then it replaces it, recreates it. So let's see the status now. We see that it's in a running state. Let's also verify that the limit that we set is now reflecting. Okay. Yep, we've just checked and made sure that it's in a running state. And the next task is to delete pod. And we'll just give it a few seconds for the process to terminate. Okay, that's the end of this lab.
Okay, so the lab முடிஞ்சிருச்சு. Next demonstrate வேண்டாம். Resource limit முடிஞ்சிருச்சு. Demonstrate lab session. Demonstrate. Okay,
Okay, so let's go through the lab on daemon sets. So the first question is, how many daemon sets are created in the cluster in all namespaces? So let's do a kubectl get daemon sets. If you look at the default namespace, there are none.
find daemon sets in current namespace kubectl get daemon set. If we name it in all namespace, then kubectl get daemon set, or I think namespace spaces actually.
But if you want to look at all namespaces, you do a -a, and we see that there.
Or kathukalam kubectl get daemon set dash captcha.
There are two daemon sets in all namespaces. It's the kube final ds and the kube proxy. So that's two. So the next question is, in which namespace are the daemon sets created in? So if you look at the namespace column here, we see that they are in the kube system namespace. So select kube system. And which of the below is a daemon set? So if you look here, we have the kube final ds and kube proxy. These are the daemon sets. Scheduler, core DNS, etcd master, these are not. It's the kube final ds, that's the daemon set. On how many nodes are the pods scheduled by the daemon set kube proxy? So if you look at kube proxy here, we see the desired and current and ready numbers are 1, so it's just it's 1. But let's also look at
describe
it in detail. So we go describe daemon sets kube proxy. Okay, the namespace is kube system, and is that. Okay, so here you can see the desired number of nodes scheduled is 1, current number of nodes scheduled is 1. So it's just, it's 1, right? And that's also because
this
cluster,
daemon set.
there's only one node, and that's the reason it's just 1, okay? And what is the image used by the pod deployed by the kube final ds daemon set? So let's look at the kube final ds a bit more detail. So describe daemon set kube final ds, then the namespace is kube system, and we see that the image is the one under CoreOS final. So that's this one.
Nice.
CoreOS final. We see then
to find a image used by pod that got created by daemon set அப்படின்னா கமாண்ட் வந்து kubectl describe ds daemon set பேர் என்ன இங்கே போட்டுருவோம் daemon set name அது ds daemon set ஓட நேம் அதுக்கடுத்து அது cube systemல namespace cube system namespace name of ds. Okay.
The namespace is cube system, and we see that the image is the one under CoreOS flannel, so that's this one. The next one is to deploy a daemon set for FluentD login using the given specifications. So one way to get the specification for daemon set is to go to the Kubernetes documentation pages and get these, right? But since the structure is very similar to a deployment, an easier way to just do it from here, from the command line, is to use the driver option for deployment and create a file and then change it and just make the necessary change. Right, so we're going to have to do a create deployment. And it's image is, we're going to do a dry run. We're going to do dry run equals client. Right? So we'll just call it this file. So the kind is going to be
to create a daemon set. Best way is create a deployment in dry run, then with that output change kind deployment to a daemon, then remove replicas strategy replicas strategy select இருக்கணும். இது ஓகே. ஸ்டேட்டஸா
the daemon set. Let's don't have replicas, so you can actually look at it and compare it here. So there are no replicas, so we're going to remove that, and this one right here, and rest everything looks okay. Let's save that file and let's create it. And the namespace is cube system, and we have that daemon set created. It's not ready yet, but yeah, that should be okay. So this is of course a very a simple example. We've not provided any kind of options or parameters for this daemon set, so we're just going to keep it super simple. But yeah, as far as this task is concerned, that's all that's asked. Okay, so that's the end of this lab.
cancel next another static pods or a lab solution இருக்கு. Video number 74 lab solution static pods. Lab solution static pods. Okay. இப்போ வந்து எனக்கு ஏன் தண்ணி குடிச்சிட்டு வருவோம். என்னம்மா சாருமா
Okay, so in this video, we're going to go over this lab on static pods. So the first question is, how many static pods exist in the cluster in all of the namespaces? So let's do get pods -a to list the pods in all namespaces. Now, one way to figure out differentiate a static pod from the other pods is to look at its name, and at the end you'll have the node name appended to it. So this one, this one, this is a static pod created on control plane. All of these three are, and as well as this. So there are 4 static pods, and then there are no others with a visible node name to the end of it. So that's one way to look at it. Another way to be sure is to look at one of the pod in a bit more detail. So let's say, for example, this one, let's do a kubectl get pod, and then we do provide the namespace, which is kube system, and but this is just going to list the pod. It's not going to give us the information that we need. We need to look at the YAML format of the pod. So we're going to do a -o and YAML. So this is going to give us a lot of information. But from this, what we need to do is we need to look at the owner reference section. So if you scroll down, there's this section called owner references, and under this you'll see the owner of this pod is the node. The kind is node, and the name is control plane. So that's one way to be sure if a pod is a static pod or not. And if you
okay, ரெண்டு வே சொல்லிருக்காங்க. How to find a static pods in a list of pods. Okay, one way வந்து kubectl get pods it will list all pods, but there we have to look for name which amend to node name. Example, pod1 underscore node1. இந்த மாதிரி இருந்துச்சுன்னா செகண்ட் வே வந்து get
You look at this screen, and if you look at same for another pod that is not system, look at the owner reference for this right here. We see that the owner of this is a replica set, right? So so this is not a static pod. So that's one for all of the pods, like using filters and selectors, and then advanced to find out if a pod is static or not. And one of that is to look for node names at the end of it, and to be sure, you can use the command that I just shared. Node as of now, or static pods, and they're all on control plane node as of now. So let's run that command again. The question is, which of the below components is not deployed as a static pod? So if you look at this, we have the etcd manager is a static pod, and kube scheduler. The core DNS does not seem to be a static pod. So let's select that. Okay, which of the below components is not deployed as a static pod? Again,
Kube proxy.
we know that all of these are, except for not a static pod. On which nodes are the static pods created currently? So all of these, as we just saw, are on control plane. So control plane is the answer to this. Of the directory holding the static pod definition files. So one way to figure that out is to look at the kubelet conf. So
pipe grep pipe grep kubelet.
So var lib kubelet, and then we have the config.yaml. And if you look into this file, so this is the kubelet configuration, and we've learned that it is the kubelet that creates the pods.
To find static pod definition files, follow below steps. ஒன்று வந்து follow below steps. Deviate about the phone is another. Follow below steps. Below steps. First வந்து ps hyphen ops grep kubelet. This will give path for kubelet config.yaml. Example வந்து var lib kubelet vi
And if you look into this file, so this is the kubelet configuration, and we've learned that it is the kubelet that creates the pods. And there is this specification here that says static pod path, and it is currently set to the etc Kubernetes manifest directory. So let's look. Look at that directory, and we see that this is there are the files that are used to create the static pods. So that is /etc/kubernetes/manifest. That's the correct answer to this question. And also remember that this is the path to check the static pod configuration, static pod path configuration on any given node. Okay, so how many pod definition files are present in the manifest folder? So that's 1, 2, 3, 4, 4, and that is equal to the number of static pods that we have here. And what is the Docker image used to deploy the kubeAPI server as a static pod? So if you look at kubeAPI server here, so this followed by this, and if we look into the image, we see that it's kh.gcr.io/kubeAPI server version 1.20.0. So as of this recording, this is the version. You should make sure that whatever the version is that you are working on, make sure you choose that as the answer. Okay, so the next question is to create a static pod named static pod static busybox that uses the busybox image and the command sleep. So we know that the command to create a pod is run, and the name is static busybox. The image is busybox. Okay, and the command is sleep 1000. Now what we need to do is we don't want to create this. Instead, we just want to get the pod definition file and place it in the static pod. So not to place any option that is for the kubectl command is going to be considered as always be at the end. So any option for the kubectl utility should be before the command option. So dry run equals client, and then -o YAML. So I get this.
To create a static pod with some command. kubectl run pod name image equal to image name, அதுக்கு அடுத்து command command sleep 1000. When you use try run, then
And okay, so we're going to redirect that. To a file. So for now, I'm going to put it to static busybox.yaml. Then I'm going to move this to /etc /kubernetes manifest folder. And let's see if it's created. Okay, so the pod is now created, static busybox control plane, and it's in a running state. Now edit
manifest
the image for simply edit the pod. And if we look at the, let's watch the status. Okay, there's a image pool issue. Okay, got it wrong. Sorry about that. Let's change that now.
சூப்பரா இருக்குல்ல இந்த கமெண்ட் to constantly get status of pod we can use kubectl get pod open watch this will give constant like live
So that's why you should always verify after you do anything, especially in the exam. It's possible that we might make typos in different places, so you always verify your work after you're done. Okay, so that's done. Let's wait for the next question. Okay, so we just created a new static pod named static greenbox. Find it and delete it. So
we just created a new static pod named static greenbox and delete it.
We'll keep looking at pods and we see that there is indeed a static greenbox.
manifest போய்ட்டு remove பண்ணாலே
We
போதும்
delete the pod.
work ஆகுது
If you look at it, it's going to be created.
Running.
The pod deleted. Kubernetes greenbox, and that's basically because if you look at deleted from total nodes and a node 01 node as an IP address. So the one is at 10.38.102.0.1. Okay. And sometimes if you just depending on how the DNS is configured, if you just do a SSH to just node 01, that might work too. But if that isn't working, then you should always look up at the internal IP address following this command and SSH to that node. So now we are on node 01. I'll manifest path. So let's, and as you see, it doesn't exist, right? So there is no static green why that is configuration config.yaml. And if you look at this file, var, just to mess with you, get you to think a little bit. So, yep, and there indeed we have the greenbox.yaml. So all we need to do is just remove this file from here. Okay. And make sure it's removed. Now let's exit and go back to the control plane. And let's watch and wait for it to be. Okay, so the pod, and that's gone. Okay, so that's that, and that's the end of this lab.
ப்ரையாரிட்டி கிளாஸ் அதெல்லாம் வேண்டாம். நெக்ஸ்ட்டு வந்து ப்ரையாரிட்டி கிளாஸ்க்கு லேப் சொல்யூஷனே கொடுக்கல, ஸோ அதை விட்டுரு. மல்டிபிள் ஷெட்யூலருக்கு லேப் சொல்யூஷன் கொடுத்துருக்கான். முதல்ல மல்டிபிள் ஷெட்யூலர்ஸ் முடிச்சுட்டு தான் போட்டிருக்கேன். ஓகே, லேப் ஷெட்யூலர் கொடுத்துருக்கான்.
Okay, so let's go over the practice test for multiple schedulers. So what is the name of the pod that deploys the default Kubernetes scheduler in this environment? Okay.
Video number 79. Lab solution. Multiple schedulers.
Okay, so let's do a kubectl get pods command. In the kube system namespace, so we're going to look here, and we see the pod is kube scheduler dash control plane. So let's select that. What is the image used to deploy the Kubernetes scheduler? Inspect the kube scheduler pod and identify the image. So let's do a kubectl describe pod
scheduler control plane
scheduler, and then specify the namespace as kube system. Okay, so here we have the image, and that is case.tcr.io/kube scheduler version 1.23.0 as of this recording. So I'm going to select that. Okay, now we've already created the service account and cluster role binding that our custom scheduler will make use of. So all of these are already created. If you'd like to take a look, you could do a get service account, my
scheduler. Practice panliyo. Multiple scheduler.
Okay, so we see the my scheduler service account.
ஆமாம் தான் நினைக்கிறேன். மல்டிபிள் ஷெட்யூலர் ப்ராக்டிஸ் பண்ணலன்னு நினைக்கிறேன். ஓப்பன் பண்ணு. சும்மா ரீஸ்டார்ட்டுன்னு தான் நம்ம பண்ணியிருக்கோம், ஸ்டார்ட்டுன்னு தான் நம்ம பண்ணல. ஓகே, ஸோ கொஞ்சம் ரெஸ்ட் எடுத்துப்போம். அண்ட் மாதிரி ஃபஸ்ட்டு டாஸ்க் வந்து 1.5 மணி நேரம் பிளான் வச்சேன், பட் 1 ஹவர் 15 மினிட்ஸ் 4 மணி நேரம் முன்னாடி முடிச்சாச்சு. கொஞ்சம் ரெஸ்ட் எடுத்துகிட்டு பேலன்ஸ் 4.5 மணி நேரம் ஸ்பெண்ட் பண்ணால் 79லேருந்து அப்படியே போயிட்டு இங்கே முடிக்கணும். 107 முடிக்கணும். பாசிபிளான்னு தெரில, பட் ட்ரை பார்ப்போம். ஸோ இதோட இந்த லைவை ஸ்டாப் பண்ணுறேன். 1 மணி நேரம் போயிடுச்சு. கொஞ்சம் ரெஸ்ட் எடுத்து வரேன், தூக்கம் வருது.